Okay, so we're going to continue with our binomial products today, and we're actually going to extend this a little bit to look at binomials times trinomials and how we can use the area model to kind of organize our thinking when it comes to larger products. Okay, so go ahead and start these 4 problems, and I will catch up with you shortly. All right, so remember, we go ahead and write our binomials on the left side and the right side, and then we're going to multiply to get each box. So again, I'm using these two for this one. So 16s squared. And the next one are the blues, so negative 32, and an s. And then I need these two, so positive 32 and an s. And my last term is going to be the 8 and the negative 8, which is a negative 64. So I see if I combine these on the diagonal that a positive 32 and a negative 32, those are gone. So my answer on this one is 16s squared minus 64. I don't write a 0s. Okay, I don't write a 0s. Let's take a look at this next one. 9d minus 6 and 9d plus 6. So 9 times 9 is 81d squared. 9 times 6 is 54. And 9 times negative 6 is a negative 54. Again, I see those opposites right there. And negative 6 times 6 is a negative 36. So again, if I combine on the diagonal, those two cross out, 81d squared minus 36, because that is a 0. All right, so what does this mean? If I have 2k minus 4 to the power of 2, well, I need to remember that that means I have 2 of those. So that's actually 2k minus 4 twice. So 2k minus 4, 2k minus 4, so that would be a 4k squared. 2 times negative 4 is a negative 8. 2 times negative 4, again, is a negative 8, and negative negative is going to be a positive. So this time things don't disappear, but I actually see that I have the same terms. So if I combine on the diagonal again, I have 4k squared. Negative 8 and negative 8 is a negative 16. Remember, I'm adding plus 16. So let's double check our math here to make sure we're good. We've got negative 8 plus negative 8. Okay, that's a negative 16. So make sure and watch those signs when you're working on this. Okay, so again, this one means I have 2 of them. So 5 minus 3r, 5 minus 3r. So 5 times 5 is 25. Notice this one's kind of backwards, but I'm going to see that my like terms are still in the same locations. So 5 times negative 3 is a negative 15r, and another negative 15r, and negative 3 times negative 3 is a positive 9r squared. Okay, so combining on the diagonal, I have 25 minus 30r plus 9r squared. So is this one in standard form? No, so we really should flip the order here and write the r squared first. And remember, the 25 is positive, and so is the 9. The negative stays on the 30. All right, now let's take a look at a bigger multiplication. So the process is exactly the same. I just have more boxes. Okay, so if I have a binomial times a trinomial, so there's 1, 2, 3, so that's a trinomial. It's the same process. I'm still going to multiply the same way. I just have more boxes. So I'm going to add a 1 and a 1. So 1 times 1 and 3 x's, because a 1 and a 2 is a 3. And I'm going to go this way. So 1x times 2x is a positive 2x squared, and 1 times a negative 8 is a negative 8x. Okay, second row. 3 times 1 is 3, and an x squared. 3 times 2 is 6, and that's a 6x, and 3 times negative 8 is a negative 24. So what I want you to see on this one is that there's actually 2 sets of like terms. So I have an x squared here, and I have a single x here. So I'm actually going to be combining on the diagonal twice. So 1x cubed, 3 plus 2 is 5, and 6x minus 8x is negative 2x and minus 24. So there's my answer. 1x cubed, or just x cubed, plus 5x squared minus 2x minus 24. All right, go ahead and draw yourself a box that's 2 by 3. And write in your terms, your factors, and multiply. See what you can come up with. All right, let's see how you did. So 2 times 3x is 6x cubed. 2 times negative 5 is negative 10x squared. 2 times 6 is positive 12x. Negative 5 times 3 is a negative 15x squared. A negative 5 times a negative 5 is a positive 25x. And a negative 5 times a positive 6 is a negative 30. Again, I need to look on the diagonal because I should have 2 sets of like terms. So if I look at this one, I see I both have x squares, and if I look at this one, I both have x's. So I'm going to start with my 6x cubed. Negative 5 plus negative 10 is a negative 25, and 25 plus 12 is a negative 37, and last but not least, I have my negative 30. All right, so see what you can do with these. Reach out to us if you are struggling. We're going to move on. Whoops, I guess we got a couple. We got one more. Let's do this area of the parallelogram and the triangle just because it's a good one to talk about. All right, so let's talk about the area of the parallelogram. Well, parallelograms are treated the same way as a rectangle. So we're going to take the 2y plus 4 times the y plus 1. So that gives me 2y squared plus 2y plus 4y plus 4. So I have 2y squared plus 6y plus 4 because I went ahead and combined on the diagonal. So there's my parallelogram. Okay, so now I need my triangle. Well, how do I find the area of a triangle? Yeah, it's base times height divided by 2. Base times height divided by 2. So the base of the triangle is y minus 1. So instead of using the y plus 1, I'm going to use y minus 1. I'm still going to use the 2y plus 4. And then when I'm done, I'm going to divide by 2. Okay, and then I'm going to have to do some subtracting because I'm looking for the area of the shaded region. So 2y squared, a positive 4y, a negative 2y, and a negative 4 gives me 2y squared plus 2y minus 4. Okay, so how am I going to divide this by 2? Well, it's pretty easy. I'm just going to take these and divide them all by 2. So 2 divided by 2 is 1. 2 divided by 2 is 1 again. So I have 1, a 1, and negative 4 divided by 2 is negative 2. So this is the area of the triangle. Okay, so to find the area of the shaded, I need to take the area of the parallelogram minus the area of the triangle. So 2y squared plus 6y plus 4 minus 1y squared plus 1y minus 2. So if you remember back to how we handle subtraction, you'll remember that I have to distribute this negative 1. So negative 1y squared, a negative 1y, and a positive 2. And I still have these guys. So where are my like terms? Where are my like terms? Well, I see that I have a 2. Whoops, I flipped pages here. I see that I have a 2 y squared and a negative y squared. So these two are like terms. So that would give me a 1y squared. And I see that the y's are like terms. So 6 plus negative 1 is a positive 5. And then I have a 4 plus 2 is 6. And there is the area of the shaded region. Okay, so we can actually use polynomials to find areas of shapes also. All right, so reach out to us if you're struggling. We're going to move on tomorrow to the next step.